I'm Sarah, and I had my mind blown by Terry Weiberg, who's at the University of Minnesota 25 or 30 years ago. And I want to tell you about it because it's related to the third grade benchmark and the new standards, the 2022 Minnesota Math Standards 3.3.6.1, which says use relational thinking, and we're going to define that, to find a missing value in an open number system with up to 3-digit whole number addition and subtraction expressions and determine if the equation is true or false. And so we're going to start by looking at the story of where Terry Weiberg blew my mind. And it had to do with this number sentence. And he said, Sarah, did you know like 30% of high school students get this problem wrong? This is like 25, 30 years ago. And I was teaching high school and I said, no way, Terry, my students are not going to get this wrong. So the next day I went into my classroom, I asked my students, and sure enough, all kinds of the students got this wrong, like 20, maybe even 30% of them. And when they got them wrong, I'm like, oh my goodness, no wonder they can't do algebra. No wonder they're struggling. And I started reading all the research because the research said the most common wrong answer was 12. In fact, at fifth and sixth grade, that common wrong answer is as high as 50% in students that they will say 12 because they're just doing what's on the left side of the equation. Somehow that's the pattern that they've determined of what they should show. In fact, the most common second answer is also wrong, and it's 15, where they just add all the numbers up. So what has created the symptoms that students are doing about this, and then what can we do about it? So I found this on Facebook this week. It's a clever little puzzle, but man, I wish they would not have used the equal sign that way, because that's not what the equal sign means. That symbol means something else, and we're going to talk about it. I wish they'd used an arrow that 9 leads to 90 or something like this. I found this on Facebook this week. There was a parent complaining about their child's homework, and I don't necessarily find anything wrong with this homework, but like if you look at this homework assignment, you will see like all the problems look like so many other assignments that we give all the way through high school. Well, what is to be done is on the left side, and they want us to put the answer on the right side, and students just learn to do that. And then they don't have what is called relational thinking. So let's talk about what relational thinking is. Here's a similar but slightly different problem that I'm going to use. I took this one from Pam Weber Harris. You'll see why in a second. And if we asked our students what goes in our box, there's a couple things our students might do correctly. So let's talk about what they might do correctly. A student who does this correctly might say, oh, 19 plus 5 is 24. And then I just took 20 away from 24, and that gave me 4. Correct answer, but it's not relational thinking. The reasoning here is a description of the calculation they did. Here's how Pam Weber Harris says it. All of her relational thinking prompts, and I've linked to it in the description down below, say fill in the blank, but don't compute. Use relational thinking. So what does relational thinking look like? Well, let's look at this problem again with some other students who did it correctly. A student might say, to keep both sides balanced, ooh, that word balance is really key, I need 4 more. Another student might say 20 is 1 more than 19. So they're comparing the first number on each side of the number sentence. So the missing value is 1 less than 5. And so they're relating the total value of one side to the total value of another side. There are lots of tools we can do this with. I'm going to show you one in a moment from Polypad, which is free virtual manipulatives online, where students can place objects onto a balance and the balance will change based on what's going on here. Here I have it as 19 plus 5 and 20, and it's not in balance. And that's relational thinking. And they might then rearrange them and add some additional squares to the balance to make it balanced. They might do that in a variety of ways, but students need to have experiences of what does it need to be balanced and have that connected to the abstract number sentences that we do. Here's what relational thinking is. Relational thinking is the ability to reason about mathematical relationships without relying on computation. To be more specific, it involves our students recognizing patterns, my favorite word if you've heard me speak, and then using the properties of operation. In second grade, it's things like the commutative property and and the associative property. So seeing when things are reversed or I can move them around and really understanding the structure of numbers that includes place value and other things to make judgments, justify solutions, and solve problems flexibly and efficiently. And so let's take a look at a problem where I've taken the numbers away and I've used the old school number sign. I know it's not a pound, it's not hashtag. In this case, it's a number sign. And we want to start thinking of that equal sign as a relational symbol. Not something we want our students to think of it that way, not as something that they should do. So instead, I've stopped saying equals all the time, and instead of replace that language in my world with everything on the left has the same value as everything on the right. Or I might say everything on the right is the same as everything on the left. And I often use the phrase balance. The two sides of the sentence need to balance. And so, as we're building this with students, let's use that language and also give them experiences. It might be with a balance, but it also just might be a tool that they've been using since the earlier grades, like 10 frames, where they put the first 19 plus 7 into that sentence, and then they do the same thing with 20 plus 6, and they look at what could I move to show that those are equal, to balance those, and to see that they have the same value. How would I make those pictures the same? And then also mix up how you use the equal sign in your classroom. It's surprising how many students don't think that 6 is equal to 6 because they don't see anything to do. So start writing sentences like that. 342 is equal to 342. And then mix it up with more things and think about how you could do that in your classroom. And then I know sometimes you want to put things down like 5 plus 1 equals 6. That's not wrong, but make sure for every one of those, you put the answer on the other side and mix up where the unknown values are with students. I also highly recommend for this benchmark, 3361, using true false statements and having students talk about those one at a time. Like this first one, you could talk about the commutative property. Oh, we're allowed to rearrange the numbers and they're still equivalent. And look at different problems, like in this one, thinking about decomposing numbers and thinking about place value and how that relates. Here's another one where we can think about, do they understand the relationship of taking 600 minus 600 away from here? And so on and so on and so on. So as you're doing these, you want to be looking at how students are answering these. And here's two students who did it correctly, but one of them has more evidence of relational thinking. So you're looking for the evidence of students thinking relationally as they're working versus calculation. So I quickly wanted to show you a tool if you don't know about it, Polypad. I have it linked down below that you can use with your students. And in this, there's an algebra tool where you can grab a balance onto the playing, like the place where you work. I've already set it up to go along with this number sentence that we've been doing today, and you can see they are definitely not equal. And students might pull in numbers one at a time, still not equal. Let me pull another one. Oh, still not equal. Another one. Nope, still not equal. Whoop. If I have 4, now they are equal. Another thing they might do, let's say they're just guessing and checking, and they really think that equal sign is to do something. Let them have a mistake and see what happens. Let them put 24 in there and be like, oh, no, it's too bad. I did too much. And let them just randomly guess and check and be like, nope, that's too much. That is going to help them build those things. And then you can talk together about what it would take for things to be equal. So if you have not used this before, I recommend checking it out and using this with your students in their classrooms. And then I just want to remind you that as you're teaching 3.3.6.1, that you also look at the progression of learning and go back to second grade and see how what is being asked of students in third grade, what kind of experiences they brought to you from second grade, and then look to see where that third grade benchmark goes into fourth grade, how those relational thinking is going to start not with addition and subtraction, but with multiplication and division and adding properties like the distributive property. So hopefully you got a glimpse into benchmark 3.3.6.1. I put some resources, including links to things I talked about, down below.